Okay, good morning, students. So, welcome to one more topic called as Ubiquitous clouds and Internet of Things. So, this is covered from the book of Huang and Fox and Novara. So, chapter number 9, which is covered as a part of it. As per syllabus, it is unit number 5. So, let's see what it is all about. So, we all are very much aware with the term called as Internet of Things. So, the Internet of Things refers to uniquely identifiable objects and their virtual representations in an internet-like structure. So the term Internet of Things was first used by Kevin Ashton in 1999. So we are very well aware with the term called as Internet of Things, or in short, it is called as IoT. So nowadays, many smart features like home safety, security, and like this. So plenty of things are coming up on with the help of Internet of Things, and the Internet of Things is really useful uh, with the help of cloud. So we say that sometimes the technology is driven by the technology driver. So one of the technology driver is cloud. The other one of technology driver is IoT. So you can see that how the Internet of Things and enabling technologies is helping us. So on the left hand side, we can see the reach is technology reach, and on the right hand side, we can see the time in terms of 10 years span. So year 2000, 2010, 2020, and like that. So RFID tags for used for some, RFID tags in surveillance security, then locating people, and now teleoperation and telepresence, ability to monitor and control distant objects. So we should be able to, we want to do that, right? So supply chain help us. So you can see that how the graph is increasing. And there are some enabling and synergetic technologies for the IoT. So enabling technologies are MMI. We call it as man-to-machine interfaces, or sometimes it is called as human-computer interaction also. Protocols of electronic communication, microcontrollers, RFID. On the other side, biometrics, machine vision, robotics. So these are technologies which are going to help, and these are synergetic technologies. So, and the left hand side, it contains enabling technologies. So this is very important diagram which often comes in the exam also, and it is also very important to understand how does IoT works in communication with the cloud to help achieve some applications. So we should see this diagram or read this diagram. Sorry, from bottom to top. So from the left hand side, we can see that there is something called a sensing layer. On the above that, there is network layer, and above that, there is application layer. So naturally, the sensing layer contains RFID labels, sensor nodes, and road mappers. The network layer contains the networking part of the cloud computing. So all these technologies which help us to transfer data from one place to another, and on the top, the applications which are going to make use of all of these. So let's say we take an example of RFID label. So RFID label is a label which is given to a product, and there would be RFID scanner or reader which will read it and transfer this information to the mobile telecom network. So mobile telecom network now holding this information, even it is holding the sensor network information, the GPS information, and it is pushed onto the cloud computing platform for better usage. So now it is available for other applications to make use of it. So let's say merchandise tracking, environment protection, intelligent search, telemedicine, intelligent traffic, smart home. So these all things are based on that. So we can take an example of GPS. So when we want to travel from one place to another, we often try to make use of the feature of Google Maps. So Google Maps works on exactly on the position of your GPS. So it is your positioning system which is going to be given as an input to the information network, the internet and mobile telecommunication, and slowly it is and so it is pushed onto the cloud computing platform. And with the help of that intelligent traffic, second last from the right side, it is going to get all this information that how many people on such and such latitude, longitude, on this direction, how many GPS devices are traveling or they are moving, they are changing their position. So based on that, the traffic is sensed. So maybe it is based on that. Uh, so this is an advantage of architecture of Internet of Things. So this is very simple diagram. As I said, you need to see this diagram in three phases as one of the layer, a sensing layer. So there is one more topic called a sensor network, and it has got sensor nodes. These sensor nodes are dedicated and do specified work all the time, and they pass this information to the sensor network, and internet is used. And road mapper is mapping of road, which is based on latitude, longitude, and the global positioning system. So what is RFID? RFID is radio frequency identification technology. It looks RFID refers to small electronic devices that consist of a small chip and an antenna. So chip typically can carry 2000 bytes of data or less. So this looks on the left hand side. It looks like that. How this on the smaller side, how you can see the how exactly how much size does it occupy. So RFID chip is next to a grain of rice, so that it is that small. So this chip contains a radio frequency electronic field coil that modulates an external magnetic field to transfer a coded information number when queried by the reader device. This small type is incorporated in consumer products and even implanted in pets for identification. So, RFID tags are used. So there are plenty of applications like this. And on the right hand side bottom, you can see RFID tag used for electronic toll collection. The European countries and the America and US and maybe other UK, these all countries are already using such kind of things. Now in India also you can find that FASTag, under the name of FASTag, we are also using now RFID tags for the toll collection. So there is definitely one feature which is kind of communicated, that the information is inputted into this tag, which is pasted or attached to the car window, and the moment it passes through and the moment it comes close to the toll booth, the reader reads it and the entire information is collected. So earlier people used to use barcodes, even many of the time still barcodes are used and versus RFID. So this difference is given, so it is backed up by data processing system as barcode. It is backed by massive data processing system. So RFID is continuously going to generate data. Line of sight, it is required for barcodes, and there is no line of sight required because it transmits the signal. So like that you can see the differences. Now RFID also comes with two type of things. One is passive RFID system and the other one is active RFID system. So what is passive RFID system? So passive RFID system contains tags which are separate, communicates with the antenna, and antenna communicates with the tags, and then it goes to the reader, and then it goes to the host computer for further processing. So we call it as passive system, where the systems are having four different stages. Where if you see the active RFID system, so the tags itself contains the antennas. So these devices are made up of an electronic circuit, a battery, and an integrated antenna inside it, and they are directly sending the data to the reader. The reader reads it, and the host computer is use that to that data. Okay, so retail and logistics technology. How is it? How RFID works in businesses? So if you can see this diagram, so the part, if you see the number one, so number one is radio tag placed on the cartons. So these are the milk cartons, and from stage number one, dairy ships carton to the grocery store. From one, it goes to the grocery store. From third, the consumer buys that carton, and the consumer takes it towards the home. And then number four, consumer when reaches home, consumer recycles that milk carton, takes out the entire milk, and recycles that carton. And number five, there is recycle places where the things are getting recycled. So carton or at a recycle center, and manufacturer produces the replacement. So like that. So the part A over here is the manufacturer tracks the product to the entire wireless radio communication technology. So entire product is tracked, that where it has gone and how it has gone. So this is RFID merchandise tracking in distribution centers. So RFID directs the packages through a conveyor system in the distribution center. So it keeps track of the items. Second, RFID item reads an inventory at a store, items in transit, so company knows up to date inventory status and can synchronize the supply chain. So it identifies the number of items available with the help of RFID. So it is pretty simple. So one man only can identify, doesn't have to prepare the list of it. So the RFID number of RFID tags missing, so grocery items exactly inventory can be counted, and automatically the person is not aware of it, and the things are sent. So like this, these are the different kind of things. So then there comes a sensor nets, or we call it the enabling technology. Sensor nets contains sensing part and the network part and the embedding part. So embedded numerous distributed devices to monitor and interact with physical part. So network devices to coordinate and perform at higher levels of tasks, right? So what is wireless sensor network? We are all aware with that term called WSN. Many projects, B students continue this project to do, right? So it contains number of nodes and it has processing power. So what is it? Self-organizing network formed by many autonomous sensor nodes. Each node comprises its own power supply, processing unit, radios, and sensors. Typically peer-to-peer communication, and there is no central server. So there are many thousand to 100 to 10 thousands of sensor node per net. So we call it as making it net. So so like this you can see in the diagram, so how the sensor nodes are used. So what is the requirement of the sensor node? So the first and foremost is they should not be power hungry. So it will be deployable in remote area without any infrastructure. So naturally, most of them are based on solar battery where they charge themselves and keep functioning. And they has to be very durable, robust to handle any extreme conditions that may happen. So it must be cheap because the large quantities are required definitely. So it must be robust and it to be deployed. For example, if you see that there are some nodes or sensors which are kept on the belt of some wild animals while counting or while tracking them. Now, once the wild animal is released into its territory, it's next to impossible to catch it again. So to just to keep track of it. So this means that the device has to function continuously. So it must be recharged automatically. It must be able to sustain uh, the climate change, whatever takes place. That's fine. So it is continuously with that animal. So it should not be too much heavy. Also, should not be bothersome. Also, should not be making noise. Should not become hot. So there are plenty of things that need to be taken care of. So these are wireless sensor network characteristics. It has limited power they can harvest or to store. Okay, and then the ability to withstand the harsh environmental conditions, right? Mobility of nodes, dynamic network topology. So there are plenty of wireless sensor network. So these are the applications where it is used: commercial applications, military application, shooter location, perimeter defense, oil pipeline protection. So these are the different ways of doing it. So this is Zigbee wireless communication, wireless control that simply works. So Zigbee is a very good application. So I'm leaving this for you for your study, the Zigbee application profile. So these are all example of Zigbee. You can always find it in this PPT. Okay. So that was just an introduction to IoT and your how does it work in tangent to cloud computing. So I thank you very much for watching. So definitely there will be some series of questions, multiple choice questions, which you need to answer based on this also. So all the best. Thank you.